Okay, welcome to the Thursday study hall for May 21. More on the same sort of theme as last time. Data sufficiency problems in which people have subpar performances because they don't really set goals. That in mind, we're going to throw a problem up on the board here in a sec, but I want to make sure to get the copyright notice on the board while the recording is happening. So there's your copyright notice. All of these problems are from the free GMAT prep software, except as otherwise indicated. Okay, let's do one. Let's do one of these things. Problem. How about this one? So this is the only problem in here because that is not copyright GMAC free GMAT prep software. This is actually from our practice test. Give it a shot. Okay, I just also typed the problem in the chat box because apparently there seems to be an issue with people with tablets and phones. I can probably do that with every problem because I don't think any of today's problems have diagrams, but it's interesting because usually tablets and phones are not an issue, but you should be able to see it now. So we know if it's good. Okay, this problem is fun. Let's pick something pretty soon here. It's been kind of a while. I'm not going to quantify what quite a while means, but at the point, remember that good time management has nothing to do with minutes and seconds and everything to do with self-awareness. I mean, when you define what good time management is on this test, it's really just being able to recognize and admit when you're stuck. And then if you're stuck, stop what you're doing and try something else if you can think of anything else. And then if not, can't think of any other approach and can't reorient yourself to the goal, then quit and move on with your life. That's all. That's good time management. So the good time management is not about counting minutes and seconds because problems will take wildly different amounts of time. And if you're stuck, then you're done no matter how long or short it would normally take to do a problem. So just keep that in mind. But there are still a lot of people who don't have answers choices picked here. I mean, there's 30 people, and we've only got about 15 votes. So should pick something. If you don't remember, I mean, in these study halls, we do expect that people do understand the basics of data sufficiency. Like we do expect people to understand what the answer choices are in these problems, but I will post them up just to make sure. These are the 5 answer choices in data sufficiency. It's a problem. I mean, again, that's a problem that, I mean, I don't hate the question, it's just a useless question. I mean, if you think about that, it can't help you, and it can definitely hurt you. So, like, if I actually give you answers to questions like that, I am impeding your ability to do well on this exam. So it has nothing to do with I hate the question. It has to do with don't think about it, because you won't know, and it'll just distract you from solving the problem. Okay. Let's run with this pretty soon. If you're in the beginning of the alphabet in particular, then you should really pick an answer choice. All the ABC people, A, B, C, D, Amy, Brandon, Brittany, Chaitanya, Griswold, Dio. Beginning of the alphabet hasn't answered the question yet. Okay. All right, this is okay. This is where it gets interesting, ladies and gentlemen. I don't usually publish the question responses, but I'll publish the statistics to this one because they are interesting. So there are 2 answer choices here that have 2 responses out of 30 or whatever, and actually the correct answer is one of the ones that 2 people picked. So, but let's do the problem. Before we do the problem, what we need to understand here is, because again, people just do not really understand how data sufficiency works and how these things roll on a very fundamental level. So here, okay, this problem has 7 quantities in it, right? There's basically 7 items total that are distinct integer prices. You know, you have 4 entrees, you have 3 appetizers, and okay. So here, if someone thinks this, if you think I need to find 7 integers, then what? Someone tell me in the chat box. If somebody thinks I need to find 7 integers, I'm looking for something more general than much more. Yeah, I'm looking for that. I'm looking for, you don't even understand what this is in the first place. If you think I actually need to find 7 numbers, then first of all, you're dead. You've already gotten the problem wrong before you even start working on it. Yeah. And you don't really understand the point of the data sufficiency format in the first place. So, I mean, this is really, really, really important here. And when I say find 7 integers, I mean actually like come up with 7 values. So, let me just clarify that. If you think I need to find 7 specific values, you're gone. You just blew the whole problem already before you even started working on it. Because, I mean, remember, the goal of this problem is not to find 7 numbers. The goal of this problem is just to find that. That's it. This is the goal. 1 value, single most expensive appetizer. I mean, the thing is that See, data sufficiency is interesting in the sense that, all right, let me give you a very simple illustration of this, because this problem is, there's a lot of moving parts in this problem, but here is a very simple illustration of this. Okay. What is 2x plus 2y? Statement 1 says x plus y is 2, and statement 2 says x minus y is 0. Okay, so here's the deal. I mean, this problem is meant to be on the ground enough for these next couple observations to be very clear. Okay, the first observation is that if you only have if you only have statement 1, then that's good enough, right? Because if you know what x plus y is, this is just 2 times x plus y, the question is. So if you have this, then you have an answer to the question, because you just multiply it by 2. You know, if x plus y is 2, then 2x plus 2y is 4, right? Smiley face if you're on board with that. Smiley face in the smiley face icon underneath your name area. Okay, yeah. But just as importantly, you cannot find the individual values of x and y. Okay, but then here's the other deal. The deal is if you pick C in this problem, then you actually find both of these together. And this is why data sufficiency is even a thing in the first place. Like with both of these, you can actually find the individual values of x and y. Now here's the point. The point is that there's a focus of this problem. There's a goal here. You know what the goal is? That's the goal. So, point is that if you are focused on that goal, you'll get this right. And the correct answer to this problem would be A. Right? Because if you notice that here you find the goal and you do not find everything else, more to the point, if you think you have to find all the values, like if you actually try to find all the values, you're dead. You'll get C here instead of A. And I mean, this is actually the entire point of the data sufficiency format. Because in a multiple choice problem, you can't do this. You can't punish people for finding too much information. Like if I gave you a multiple choice problem where you could find out that x was 1 and y was 1, then sure, 2x plus 2y would be 4. But here, see, here's the thing. Like with this single statement, that's enough to find what that is, but it's not enough to find x and y, and that's the point. And if you mistakenly think that you need individual values, then you will get the entire problem wrong. So basically, you know, here's the take-home point is this. And remember, this is nothing less than the entire point of the existence of data sufficiency. Like when a data sufficiency problem asks for only a piece of the information in a problem, like here it's just a sum of x and y instead of what are all the values. So you should expect to find that piece, but you should expect not to find all the information. And most importantly, the deal is that if you find all the information in the problem, especially by picking choice C, you are almost certainly wrong. Because again, this is the reason why data sufficiency is a thing that exists in the first place. So this, take-home point. This is not the same as the notion of seed traps, which we've talked about in other study hall sessions, but give me a smiley face if you follow me here, at least on some level. Yeah, the point is just to focus on goals. Yeah, focus on that piece of the problem. So here, if you think I need to find 7 values, you're dead. And in fact, the most popular choice here is C, which really does give you all 7 values. But no, it's not how this problem works. So, okay, we've also had sessions on word problems before. The basic deal with word problems is that you should separate the tasks of organizing. So first, physically organize the problem. Then import information from the problem statement. And then finally, solve. And information means 3 kinds of things: numbers, relationships, and of course the goal of the problem. So physically organized, there's 7 things in this problem and they're all different. So physically organized just basically means in this problem to make 7 blanks or 7 columns or something like that. So 4 entrees, entree 1, entree 2, entree 3, entree 4, and then 3 appetizers. That's it. Notice we can also put these in order from most to least expensive because we know that the entrees are all more expensive, and we know that all 7 numbers are different. So this can be ordered by price. So let's say, just to remind yourself of that relationship again, you can even put some inequality symbols in there. There. Those are all facing the wrong way. Just kidding. Entree 1 is the most expensive, then entree 2, then entree 3, then entree 4, then A1, A2, and A3. Okay, cool. All right, there, we organized it. And then we should have 2 copies for the 2 statements. So there, we did it. Statement 1, statement 2. That's supposed to say 2. Okay, physically organized, we did it. All right, now let's bring in the information. By the way, also you've seen this little split decision thing. With data sufficiency, if we face a data sufficiency problem in our lives, we pretty much have 2 ways that we can approach it, which are to try to throw theory and stuff at it, or to just test cases. You might expect this with this problem, but there is no way that you can solve this problem algebraically. Because first of all, there are 7 moving parts, none of which has any obvious algebraic relationship to anything else. 7 basically independent values. But on top of that, they're all integers. And as you might know, if you are given that things are integers, they're basically already telling you that you cannot use algebra. Because the algebra doesn't know how to distinguish between integers and otherwise. So in this problem, we're definitely going to have to just test cases. If you're not super familiar with that, there are plenty of study hall recordings, archives that are basically just about testing cases. Okay. Let's import information. So the total cost is 89. Just write that on there somewhere. Total is 89. You don't need to be super fancy about it. Okay. Also, you should write they're all different. Just to remind yourself that you can't use the same number twice. And then we've already got everything costs more than everything else because these are all greater, so we're good there. Okay, guys, what's the goal of the problem? What's the point of all this? What are we trying to do? We are trying to find the number. We're trying to see whether we can find the number where. In Let me know. Can you hear me? I had a little bit of a blip there on the internet. Near my finger. Yeah, it's the one that's not quite at my finger, but yeah. I'm going to try to find A1. Okay, loud and clear now is good. With me, it's mostly just loud and loud. So loud and clear is a good thing, right? Yeah, A1 is the point. The point is A1. Can we find A1? More specifically, the point is actually to see whether we can give A1 two different values. But the point is that this is the focus of the thing. I mean, you don't get to use all these cool colors when you take the real test, but you should definitely imagine that the cool colors are there. Right, so focus, guys, the thing. And I mean, remember when you test cases, again, make sure that you know this deep down in the bottom of your heart. When you test cases, the goal is always to try for not sufficient. So remember, when you test cases, you're trying to make two different things happen. In this case, that means you're trying to put two different numbers in the column that says A1. Okay, let's try that. So number one says that this has to be 16. Statement 2 says that this has to be 9. Okay. So, you know, $89. If you have to have 16 as the highest value, then to get to 89, you're going to need, are you going to need the other values to be sort of high, relatively speaking, or sort of low? If you're going to try to get to 89. Yeah, they need to be sort of high, right? Because if you have one, and if you don't see that, by the way, you can just try putting small values in these places. If you try putting, you know, 5, 4, 3, 2, 1 here, then this is going to be 15 and 16 is 31. You would need like $50 here. So that's not going to happen. So if you just try that, you'll realize very quickly it won't work. So yeah, let's just try high values. So 15, 14, 13, 12. So far, that's the same as 5 times 14. That's 70 so far. So we have $19 left. You can do 19 is 10 plus 9. Notice that I could do the same numbers and then I could have 11 and 8. Does that mean that the statement is not sufficient? Is that what that means? Does that mean the statement is not sufficient? Question mark, question mark. No, it does not. Well, it doesn't mean it's sufficient yet. I mean, you have to actually show that you can't do it. But the point is this is not two results. Because you have not, this is the only thing that we care about right there. And you haven't actually found a second value for the thing that we care about. So this is not, there's no point in wasting your time changing other values. I mean, the point is that we need to try to change this because this is the only value that we even care about. So it's our only goal in life at this point is that get a different value here. All right. Well, you should probably realize we can't go up with this number because this number is as big as, I mean, these 16, 15, 14, 13, 12 are as big as they can get. So the only thing that we could try to do here would be to try to put in 11. But there's where we took $1 away to do that. is there anywhere, so basically I have to add that dollar back somewhere so that I can keep the same total. I mean, I don't need to keep doing arithmetic and subtracting from 89. You know, we can just put a dollar back somewhere. Is there anywhere to put the dollar? There's not, right? Well, let's see if we can just try to put it somewhere. Well, if we put it here, we'd have 2 16s, so we can't do it. If we put it here, we'd have 2 15s, so we can't do it. If we put it here, we'd have 2 14s, so we couldn't do it. And then if we added it here, we would have 2 11s or 2 10s. So there's nowhere else to put that dollar that we just took away. So this is not going to work. Nope, can't do it. Not a thing. And that means, you know what you can't do? You can't make this any smaller. Like, the only possible value is 12. That's the only number that you can have here. This is sufficient. Notice you cannot find all 7 values, because as we noticed earlier, you could actually have 16, 15, 14, 13, 12, 11, 8. And so if you think that your goal is to find all the values, then you will get this incorrect, because you'll think this means not sufficient when you come up with these 2 different groups. But these are not 2 different results, because they both have 12 here in the spot that you care about. And remember that that's the point. Okay, so that's sufficient. You can't make that anything but 12. Statement 2. So the idea is that we don't really want to do work that we don't have to do. So this whole case of 16, 15, 14, 13, 12, 10, 9. And we can just import that into statement 2 from statement 1. Just import it. Let's see. Yeah, okay, Tommy, I understand the question that you're asking, although sometimes it is very annoying to try to do that. So, like, meaning sometimes testing cases for one statement is really simple, but testing cases for 2 statements together is surprisingly, annoyingly hard to do. So, also, you might find, I mean, the other danger there is that if you have a problem like this one, like in this problem, there's only one group of numbers that actually satisfies both statements. So if you do that, you might mistakenly think it's D-dog. So I'd be careful with that. If you know exactly what you are doing at all times, then you might save a small amount of time by doing that. But I want to emphasize the word small there. I mean, yeah, I don't know. I mean, for me, that's too much chess playing. There's too much risk involved there, because if you might forget what the focus is, but you can try it. I mean, the best advice I can give in response to that would be to just play around with methods like that and see if they work. I would suggest that if you are at a point where methods like that are easy for you to use, then you are way more than ready to just go sit for this test and get it over with. So there's also that. Okay, but we can import this case down here, right? Why do work if we don't have to do work? Now, what's the goal? What are we going to try to do here? We got 12 here. Different value for A1. Which value? Like, what value should we try to put here? You could try to go up to 13 or down to 11. Which one is a better idea? Let's try to put 11. Because if you try to bump this up to 13, you're going to have to bump all of these up, and that's going to be really annoying. So let's try to put 11. Okay, I took $1 away. So the point is to add $1 somewhere else. Where can I add $1? I can just make 16 go up, yeah. So, not seeing what you're saying about 31, but you can just put $1 on number 1, on the most expensive one. A2. You can't add it to A2, because if you add it to A2, you're going to have 211. But you can put it here. So that's it. Took $1 away, add $1 back, because this is not tethered at 16 anymore. Remember, you have to realize that statement 1 is not a thing anymore. I mean, this number doesn't have to be 16. So we can have 17 here, and we win. So this is 2 different results. And so that's not sufficient. So overall is A, alligator. Any questions? Notice the take-home points here. You find the thing you want. You do find A1 in statement 1. Most importantly, you do not find all of the numbers. You do not find all of them. You find just A1. I mean, you find a couple of these other ones, but the deal is that, see, if you think you have to find all the numbers, then you will think the answer is C, and you will be incorrect. That's the biggest take-home point here. The next biggest point is the organizing. Most people don't do that well here because they don't do simple things like draw 7 columns and realize and mark this column as focus, and all that sort of simple bookkeeping type stuff. They try to keep all that stuff in their heads. Don't keep all that stuff in your head, guys. It's way too hard to do that. Okay. Any other questions about this one? That is a question whose answer is not useful to you, so I'm not going to answer it. I mean, yeah, level of the question, guys, don't think about it. I mean, just think about the fact that you have to ask that. Think about what that implies. It implies that you don't know the answer to that, and you never will. So no point in thinking about that at all. Totally useless. And the best case scenario is that thinking about difficulty level is totally useless. That's the best case. The worst case and the more likely case is that it will hurt your performance by distracting you from the problem. Like, here's the point. I mean, here's a stupid but effective thought experiment. Someone's going to fire a gun at you for the next 5 minutes. And you have to dodge the bullets so that you don't die. Yeah. Your job is to stay alive by dodging bullets. If you think about how hard was it to dodge that last bullet, you know what that means, right? It means you're more likely to die. I mean, you need to think about nothing other than dodging bullets, is what you need to think about. I mean, hopefully this is obvious. But the point is, the same thing is true about this test. I mean, if you think about anything like what is the difficulty rating of this problem, then you will not have any such brain power left to solve the problem. You're like stealing IQ points away from yourself by doing it. I mean, don't do it. Just solve the problems and do it. The answer to the problem is that. Alligator. Okay. Let's do another problem. How hurt is that? I don't understand what you mean there. How about this one? Right. How about this one right here? If you don't phone people, tablet people, do you guys see the problem? I'll just type it in the win. This is a very easy problem to type. So here, problem is this. That's the question. And that's statement 1. And that's statement 2. Go for it. Okay, we're trying to pick an answer to this thing pretty soon. Most of you still don't have an answer choice picked. Cha, if you're trying to say hi in the chat box, then hi, hello. If you're trying to say something else, then I'm not really catching it. Yeah, remember that the answer choices are something that we do kind of expect that you know by this point, but that's what they are right there. So that's how, there's your choices. Okay. I don't know what star answer means. Maybe explain that. Okay, let's go ahead and pick something, guys. Okay, so what is the goal of this problem? What is the goal of the problem? What are we actually trying to do in this problem? It's one of those yes/no type questions. Is period M. So, but what is actually the goal in any yes/no type of question? It's not just to try to make that true. Because remember, like, okay, here, there are two possibilities. The first is yes, m plus z is positive. Second is no, m plus z is not positive. Okay, here's the deal. All right, here. How would you program a computer to recognize whether something was sufficient or not sufficient in this problem? Who would you program into the computer? Like, how would the computer know if it was done? Weird, mysterious silence. I think that's kind of what the problem is, right? Is weird, mysterious silence. So remember this graphic from the front of this study hall. I mean, really, see, here's part of the problem. Like, if you have this, I mean, I would hypothesize that you're kind of in this dangerous territory described by this quotation right now. Because sufficient is not a thing that you can see with your eyes. I mean, how do you know? Like, how would you explain to someone else? Or how would you program into a computer? Like, I mean, let's say you were programming this. So basically, if something happens, then that definitely means, and then that second blank should either be sufficient or not sufficient. So someone fill in these two blanks here. So this second blank should be either sufficient or not sufficient. The first blank could be anything. You may fill the blank in. If M is greater than C, that doesn't tell us anything about this. If you just make M plus Z greater than 0, though, then that doesn't tell you sufficiency or not. Because there's still the question of whether you can get the other thing to happen. I mean, let's say you were actually programming this testing cases thing into a computer. I mean, some people here are probably computer programmers. Think about how you would do that. That's one way it can happen, but it's not exhaustive. Like, I mean, it's possible for this to be sufficient without necessarily having both positive. I mean, that's the way this one does work out, but more generally. Like, let's back up a step and, you know, just make sure that you guys know what the point of all this thing is. I mean, here, sufficient, not sufficient means both of these are possible. And sufficient means one of these is possible and the other isn't. I mean, which one of these is actually a thing you could program into a computer? Can you program a computer to recognize when two things have happened and then to stop? Or can you program a computer to recognize when something is impossible? I mean, there's only one of these that you can actually program. I mean, computers don't know when things are impossible. I mean, that's not something you can program with a computer. Computers can just do things, and if a certain result pops out, they can do other things. But computers don't, like, know if something cannot be done. It's not a thing, right? So the point is that this sufficient is not a goal here, because you can't try for this. This is not something you can try for. This is not a goal. On the other hand, this is actually a goal. I mean, you can, of course it is. You can just try to make two things happen. So that is the reason why data efficiency is a thing. This is our goal. I mean, again, you gotta tell. I mean, this is actually a thing that you can clearly tell when you have reached it. Like, if I make both of those things possible, then I'm done, and it's not sufficient. So just remember this. That's the goal. The goal of yes/no questions is to try to prove insufficiency. So, in yes/no problems, your goal is always to prove not sufficient. In other words, to make both possibilities happen. Just keep this in mind. This is always the goal, because this is the only thing that can be a goal in one of these problems. So that's what we're trying to do. So smiley face if that makes sense. So let's do this. Let's do this problem. So here's the problem. Remember that there are two possible cases. The first is yes, M plus Z is actually positive. And then the second one is no, it's not. By the way, as soon as you translate these, no more yes and no. Don't think about them anymore. Because again, yes and no are not goals. Like yes and no are not things that exist in a math problem. So if you think about those, remember, don't think about those. Translate yes and no into things that actually exist in the problem. Because you can't do a bunch of math and have the word no pop out. Like if you're thinking about yes and no, then you don't really have goals that are really goals. Because yes and no are not things in the problem. So here, if you can make, basically, can I make m plus z greater than 0, and can I make m plus z not greater than 0? And then you can just make a chart, right? So basically for statement 1, for statement 2, and then for both if necessary. And then if you can check off both of these boxes, then it's not sufficient. So if I can check both boxes, then not sufficient. That's the point here. I mean, you should set up the yes/no style questions in this way. You should just do it and make a habit of it, because this is the goal. Okay. Now, see, here's the other thing that's interesting about this. So, Cha up there earlier in the chat box rephrased these two statements, and that's kind of cool. It's kind of a cool way that Cha did that. And so let me comment a little bit on this. Like these are useful these are useful transformations of the statement. Meaning that it's probably much more intuitive. Like it's probably much easier to see intuitively what m is greater than 3z means than to see what m minus 3z is greater than 0 means. But see, here's the thing, right? What you should do is when you review these problems, you should experiment with transforming the statements, because you might be surprised by some of what you discover. Because, for example, if you have something like this, which can be transformed into something like this, I mean, this is relatively unintuitive, that first one. I mean, like, this doesn't really have any immediate intuitive meaning. But this is much more intuitive. On the other hand, if you have something like this, which is in the question of this one, then if you try to make the same transformation, you'll find exactly the opposite. If you make this m is greater than negative z, you'll find that this is essentially meaningless. Whereas this is actually quite intuitive. And the only way to really get a handle on that is to play around with these things when you review. You know, because like if I tell you that m plus z is greater than 0, like, I mean, when can you add two numbers and get more than 0? There's basically 3 ways to make that happen. What are they? Like when will two numbers add to a positive? You can have two positives, you can have one of them be 0 and the other be positive. And then you can have not just positive and negative, you need to be more specific than that. You need to be like, so you can have two positives, you can have positive plus 0, And then let's not think about absolute value, because why would we want to think about hard things when we can think about easy things? You can also think about positive big and negative small. There. I mean, you can actually just figure this out by staring at that for a sec and just kind of thinking about it. Yeah, I mean, I'm not in your head, but I would bet a lot of money that by looking at this, there's no way you would figure that out. At least not without transforming this into that first. So what's interesting is that you might, because this is not symmetrical. I mean, like, these both look like each other, these statements do, but transforming this statement helps you, and transforming this statement turns it into total nonsense. So just mess with that. Just play around with that and see what happens. So, okay, let's import this stuff on the next page. Cool. Let's do it. So here's the problem again. Here's our little device that we made. All right. And then notice we have a certain amount of insight for that first row of that device. So let's import that as well. These are the three ways to make that happen. Okay, so statement 1 tells us that M is more than 3Z. So if you have this groundwork figured out, I mean, the problem is that I can definitely make this happen with positives. I can definitely also make it happen with negatives. Or I can even have M be positive or Z be negative, right? But the point is, remember what your goals are. Your goals are this and this. And this is something that I can definitely do with negatives, with positives. And it is something I can also definitely do with negatives. So I can definitely check off both of these boxes. I mean, if you have to test specific cases, you can, but hopefully if you have a clear sense of goals here, then hopefully you don't really have to do that. So that's not sufficient. Statement 2 you can transform into for Z is greater than M. I mean, again, this is very doable with both positives and negatives. So there's no reason to actually test the cases if you are on board with that whole idea, because you can do it with positives, check mark, and you can also do it with negatives. All right, now what about combining the statements? So we know that M is more than 3Z. We also know that M is less than 4Z. So in other words, what? We know that M is between 3Z and 4Z. What does that mean? You can do that. We'll look at that in a sec. Although here we're not adding the inequalities. In this approach I'm showing right now, we're not doing that. But yes, we can do that. I mean, because if you have, right now we're just noticing the information that we already have. Like if you know this, then that's this. And if you know this, then that's this. So, yeah, but think about the fact that 3Z is actually less than 4Z. That's not a trivial fact, because with negatives or 0, that doesn't work. right? If 3z is actually less than 4z, then z must be positive. And so then, since m is stuck between these positive values, m must thus be positive as well. So both m and z are positive. And so therefore, there's no way these are going to add up to anything but a positive value. So that's going to happen. That's going to happen. This is not going to happen. That's suspicion. So there you go. You can also add the inequalities. That's also a thing, as Romy is pointing out there. And I think, Kanan, I think that might be what you are also asking. They're not equations, so if you want to get technical about it, it's not a system of equations. But I think you're asking about the same thing that Romy is asking about. You can add these because when two things are both greater than two other things, you can just add them. So if you have, sure, right, if you add these, then you get, the m's go away if you add them. 4z minus 3z, that's z. But notice you have to make sure that you still remember, because this doesn't just mean z is positive. I mean, this means you also, we still know, right? We still know all the facts that we have up there. And we still know that m is greater than 3z. So therefore, there. If you transform this into m is greater than 3z, it should be pretty clear that you can do that with negatives. I mean, m could be like minus 10, and 3z could be like minus 3 million. And then that would make this work. So, because you can do this with negative values. Therefore, that should be good enough. Let me know if that makes sense. No, yes, no. No, no. Are you live? Not alive. Okay. All right, cool. Any other questions about this one? Okay. Let's see, about 10 minutes left. Let's see if we can do one that's quick and dirty. Let's try one with that one. About how about this one? Let's see. All right. So this one, let's do it. In order to stay within the time that we have here, I'm going to kind of fast forward through discussion of this one once we're done. But give this one a shot. Okay, let's pick a thing here. In order to stay inside the time frame that we have here, we're going to start discussing this pretty soon. But if you have to make a guess, then make a guess. Again, for some reason, it's the beginning of the alphabet that doesn't really have answers here. Brandon, Casey, Cha, Chaitanya, make some guesses if you have to. Okay, here, let's try to do this whole discussion relatively quickly so that we can wrap up here. But notice that, first of all, this is kind of fake. I mean, this question is not really about probability at all. So that's the first realization to make. This isn't really a probability question at all. At least not in any sense that that is not trivial. Because I mean, what does it mean for this to be greater than this? Yeah, it's just like saying, are there more red balls? That's it. I mean, this question is just, are there more red balls than white balls? Sure. And I mean, notice one thing about these problems is these problems will never test two different concepts like simultaneously. So inequality fractions and probability not really going to be tested together. So if it looks like it's testing a multidisciplinary problem, so to speak, then one of the concepts is probably just trivial. Like, is there a greater chance that I will choose a red ball than that I will choose a white ball? Just means, are there more red ones? So, smiley face if you're on board with that. I mean, that at least makes your life easier here, because we can just say, is R more than W? That makes our life easier, for sure. Okay. So now that we know what the real nature of the question is, then we're ready to tackle it. Okay. So statement one. Statement one is a little bit weird looking. So let's go ahead and make that device here. So we do have two, there's going to be a yes case and there's going to be a no case. So can I make R greater than W? And can R be greater than W? Or can it be less than or equal to W? And then these are my two cases, and then I'll just have statement one, and I'll have statement two, and then if necessary, both. Okay, can I check this off? So, can you do that, R plus? Let's see, add 1 to both sides of the inequality. We'll try that. That's possible. Yeah, all right, I can see how you're doing that. I don't understand. I mean, I'm not really loving the whole very easy and 5 seconds thing. That's almost like you're trying to thumb your nose at the other people in the class. Seems sort of self-aggrandizing for not much of a reason. So weird, but that might be a cool way to solve the problem. So let's take a look at that in a little bit. But if you see, I'm reluctant to teach methods like that just because they're not very intuitive. Like if you don't think to do that, then you won't think to do that. But like let's talk, because I mean you're not going to have to do tricks to these things to solve them. I mean sometimes you will be able to, and it's cool. But you won't need tricky solutions. So like let's say that we just wanted to do, let's just multiply by a common denominator the way that we normally do with fractions, right? So 2 fractions we can multiply out by a common denominator. So okay. Why does it say denominator? Okay. Here, let's just common denominator. Let's multiply by common denominator. All right, so we can do b plus w, b plus r. So again, cross multiply is not really a thing that exists. I mean, if you You can, but then see the problem is it's hard to know. I mean, notice that this is what cross multiply actually is. So, I mean, the thing is that cross multiply, it doesn't even matter which one is on the left and which one is on the right, right? Like if you, I don't know. I mean, there is a thing with that, but then my brain won't remember which one's supposed to be on the left and which one's on the right. I mean, just make sure that you are be aware of fake operations and what they actually do mean. For example, cross multiply is not really a thing, and neither is cancel. So cross multiply actually means multiplied by both denominators. And cancel could be any operation depending on the context, but it could be, you know, just make sure, because I mean, there will be data sufficiency problems that specifically test whether you actually know what these are or not. So watch it with that. But okay, but when you quote cross multiply unquote, this is all that you're really doing. So that means that we have R times B plus R is greater than W and B plus W. Now here's the deal. I mean, remember what we're trying to do. The goal is to compare R and W. That's the only goal in our lives right now. So let's think about that for a sec. With you, yeah, you can just kind of think about what that means, right? Look at the positions occupied by R, and look at the positions occupied by W. So basically, just here you have blank times B plus blank, where the same thing goes in both blanks. I mean, what should be clear if you think about that is that if the blank gets bigger, this expression will be greater. So if you're putting, it doesn't depend on the value of B, not at all, because these are all positive numbers. Right, like if I multiply a smaller positive by a smaller positive versus a bigger positive and a bigger positive, well, this one's going to be bigger, dude. So like if I know this, then I know that R is definitely more than W because everybody is positive here. And as NL pointed out, if you could have negatives, that would kind of screw this up, but you don't. So if this is bigger, then this is smaller, and so that means that R is bigger and W is smaller. So this means that this is a thing that we can get, and this is a thing that we cannot get. So that's sufficient. So that's kind of neat. Let's take a look at the method that Romy posted earlier. Let's leave the parts that are actually helpful and edifying. So let's take out the rest of that. There. Okay, that's the constructive part. Let's see what that is. So if we have, so if we add 1 to this, then let's see what happens. Okay, that's B, so 1 plus, and then on both sides. So that means B plus W plus R. And then W plus B plus R. And then our denominators are B plus W and B plus R. Yeah, okay, because these are the same as each other, these two denominators. So that means that if you divide the same thing by this and by that, same top of the fraction. So if this fraction is bigger, that means that must be smaller. So b plus w must be smaller than b plus r. So w, yeah, I mean, this is obviously not easy, but this is definitely a thing that works. I mean, but you have to think to do this. And so if you think to do this, that's great. That's a really cool solution. But if you don't think to do it, then you don't think to do it. Like, notice what's cool here is you don't have to do any special things. You can just multiply out by a common. Yeah, see, that's the point, right? The point is, how do you think to do that step in the first place? Because the GMAT will not, the GMAT will never have a problem that requires steps that are just kind of like divinely inspired like that. Like, there's no clue there that you should multiply it, that you should add 1 at all. That's, you know, the GMAT's not going to require you to have that much mathematical insight. So, like I said, it's really cool that you have that much mathematical insight here, because I sure as heck wouldn't. I would never think to do that in a million thousand years, personally. But, so I think it's awesome. But this is just your standard thing that you do with fractions. Like, if you want to compare two fractions that are positive on the bottom, you just multiply through. So, I mean, I like this. I think this is really cool. But even if you do come up with something like this, I would suggest that when you review, that when you don't see it that way, it's that way. Even if you come up with cool things like this, when you review, you should go back and make sure that you could do it with methods that are closer to the ground. So we do have to wrap up pretty soon, as in very soon. But statement two, we just know that b minus w is greater than r. So you can also rephrase this as b is more than r plus w. So this, I can definitely make either of those bigger here. So if you have this, like this could be like 3 and 5, and b could be, I don't know, 10. But this could also be like 10, this could be 5 and 3. That's what 2, 3. So therefore, this could go either way. Statement 2 is not sufficient. So there's A, alligator. Okay. Since B is on both sides, you can, could I generalize what? Oh, no, I remember the whole point of my discussion of this is like, I would not even worry about this kind of approach. I mean, this approach is like, I had a vision from God and I decided to add 1. I mean, I wouldn't even worry about it. If you didn't think to do this, then don't think to do this. It's fine, because you can just do normal stuff like that. Okay, we are like way over the time limit here, so we got to stop. Thank you guys for coming. Let's see, the next one is, I want to say the next one is just in 2 weeks again, but let me just make sure that that's true. The next one of these is going to be on, what is that, June something. Next one should be on June, I'm pretty sure it's in 2 weeks from now, but go ahead and check the web page for that either way. And thank you. Is it in 1 week? I don't think it's in 1 week. I don't think we ever put 1 week. I don't think we ever had these consecutive weeks, but I don't know. Just check the website for it. And okay, we're good. Yeah, June 4th. Okay. All right, guys. Thank you, and have a good night. Good afternoon, good evening, good luck. Talk to you next time.